Okay, going to do a quick little training video on a starter solenoid or a continuous duty solenoid, whatever you might want to call it. All of our spray trucks have these typically mounted behind the seat, and this is what supplies primary battery power to all accessories on the vehicle. We try not to cut into the vehicle's wiring harnesses as much as possible. So this is kind of the heart of what makes the entire electrical system of the spray truck function without interfering with the vehicle's electrical system. So the heart of that is an electrical solenoid. We didn't have a new one here, so I found this old cruddy rusty one to use as the demonstration here. But basically what this is a remote switch. If you've watched our video on relays, this is nothing more than a relay that is rated for higher amperage. So the relays that we've posted up before will work up to about 30, maybe 40 amps a draw. These starter solenoids or continuous duty solenoids, depending on which one we pick, are rated for closer to 300 amps. So when I say a continuous duty solenoid, what that means is these are very similar to solenoids used to engage the starter on a vehicle. The difference between these and a starter solenoid is only designed to be activated for 30 seconds or a minute while the vehicle is cranking. These solenoids are rated to be activated continuously if they're called continuous duty. Can you go up and grab, there's a Cole Hersey book in your office. Can you see if you can find it? Do you know what I'm talking about? Or no, haven't you seen it?
I haven't seen it.
It's a yellow book about the thickness of a magazine that says Cole Hersey on it. It might be yellow and blue, and it's the book that we use to order these. It might even be out here on the table. You can look there as well. But all right, so anyway, that's what a starter solenoid is. Its only purpose in life is to remotely activate a switch. So if you were to think of a manual switch, the purpose of this solenoid is to be able to remotely turn a switch on and off. So I'm going to draw that up here on the board quick. This is our solenoid here. It has a big post on both sides of it, like the one that we have in front of us. What's inside this is there's little copper lugs on the inside of that post, and there's a big copper disc right here. And attached to that copper disc is a metal slug, I'll call it. And I actually have one right here. That's the disc that we're talking about. And right here is one of those solenoids that we talked about. You got a good close-up of that? That's the solenoid housing, and that's the copper disc with a lug on it. I'm going to pass this around while I'm talking for you guys to kind of eyeball. But so what happens in this case is if you were to take that copper disc and push it down with your thumb, you could manually connect this copper lug with this copper lug. Make sense? Easy enough? So if I have my battery and I have a negative and a positive off my battery, if I run a battery cable to one of these copper lugs and I run this to my spray system, if I stick my thumb in here and I push down on this copper lug and I make this connect to this, that's going to turn a switch on and cause power to pass through it. Easy enough? So how do we do that electrically? Well, a solenoid has one or two small posts on it. I brought a couple of different ones in here. Here's another style. It's got two posts on it, two small posts and two large posts. This one has two large posts and one small post. This one has two large posts and two small posts. There's a whole bunch of different combinations. Here's another one, two large posts, one small post. Okay? Why one or two small posts? Well, what causes this solenoid to work, and I'm going to make this solenoid a little bigger just for reference, just for illustration purposes, we'll say. Okay? What's going on inside this lower part of this housing is if there's a screw right here, a small post screw, hooked to that is a wire. And that wire goes round and round and round and round and round and eventually ends at another screw. Okay? If you remember from 8th grade science, if you took a nail and wrapped a wire around the nail and touched a battery, positive and negative to both ends, you would make an electromagnet. That electromagnet creates a magnetic field, and this iron, what did I call it? Iron post, iron stud, whatever you want to call it. That iron stud is drawn into that magnet. So by putting power here and ground here, we create a magnetic field within this solenoid, and it pulls that solenoid down, and it takes that copper lug and it touches these two copper lugs. Okay? That causes power to pass through it and turns a switch on. Real easy. Well, what about when there's only one post, or when there's only 3 posts total, one small post on the solenoid? What's going on there? Well, it's really quite easy. What they do is they just attach the other end of this coil wire to the body of the solenoid. So if the body of the solenoid has holes in it to mount it, it's going to get its ground from wherever you mount it. So if you take that solenoid and don't mount it to something that has ground, then the solenoid's not going to work. Okay? So let's take a look at that in here. In this particular case, this is a 4-post solenoid. Everything down below here that's the book. Everything down below here is an electromagnet inside this core down below. Okay? You can see that one of these posts come in, and there's a little teeny tiny wire that attaches to that post right here, and the other little teeny tiny wire attaches to the other post. So in this particular solenoid, you put power to one side, ground to the other. That'll create the magnetic field. This one is a little different. You can see in this one, the little stud has a little tiny wire ran to it that goes down into this coil, but the other small wire that comes up is actually soldered right to the body, just to the frame of that solenoid. You see that? Okay, so what this has got, let me back this up a little bit. What we've got here is, now we've learned that all this is here is a stud coming into the solenoid to a copper lug. This is a stud coming into the solenoid to another copper lug. There is no in or out to this. It doesn't care which way it goes. Either side can be positive. Either side can feed the other on this particular type of solenoid. There are other types of solenoids that's not true on, but for our purposes on this video, we're going to talk about this particular type of solenoid that has an internal coil that goes to a small stud and is internally grounded. In this case, this side and this side are interchangeable. It doesn't matter which one's in, which one's out. Okay? This right here is our copper lug. All right? The copper lug is sealed, it's insulated from the iron stud by this fiber washer. There's a fiber washer on top of it, a fiber washer on the bottom of it, and there's a fiber washer down inside it that you can kind of see there, probably not. But basically this copper washer right here does not conduct electricity through to this electrical, or to this iron stud. This iron stud here's only purpose in life is to be drawn down by the magnet. The copper washer's purpose is to make a connection from here to here. Make sense? Mm-hmm. So, it has a light spring on it. If you didn't have a spring on it, it would always make a connection. Let's hook up some of our stuff here. What we're going to do is I'm going to put power to one side of the solenoid. And I've got my test light hooked up. So if I touch power, I get a light. Okay? I'm getting a light here. Okay? My copper washer is making that connection through these. If I put that spring on the copper washer, once the lid is on this as well, it holds it down so it's in proximity of that, but it's not touching. Okay? So here, I gotta make a good connection. It's moving on me. Okay? That's how that solenoid works manually. Now I don't want to sit here and have to hold this down with my finger. So what I can do, I need an assistant. Don, come on over here. What I'm going to do is with my finger, well, you know what, Don, I'll let you do it with your finger. How about that? That way you can get electrocuted.
All right, where do you want it?
You won't get electrocuted, everything's 12 volt. I want it right here on this. I want you to hold this, feel that, just run that up and down a couple times. I don't want it to touch, but I want it fairly close. So you gotta let it up just a little bit. Okay? Push it down once. Okay, let it up. Now hold it right there. This is our third wire. I'm gonna just touch it to power. And nothing's gonna happen. Push it down a little bit. Do you feel it trying to take it from your finger or no? Okay, well, somehow we've broken this solenoid in the last 5 minutes. So this is a poor example. All right, let me see it. Yeah, something's broken in this since we started, so let's switch to a different body.
But it's supposed to energize it, and the magnetism pulls it down?
Yeah. All right, so this is the exact same thing, but now we have 2 studs on it, all right? One's positive, one's ground. So what I need to do now is I need to add a ground circuit to this. Our trucks usually don't use this type of a solenoid, but you can see what I got going on here is pretty simple. I have power from my battery, power coming into the solenoid, nothing's coming out right now, and I've got ground from my battery running over and grounding one of the small lugs on the solenoid, and it's ran out to a test light. Okay, now if I put this in here and I touch to the other side, I can push this down and make a connection, turn the light on, right? All right, Don, you're back up. Hold that down within proximity of that, but not touching it. I got another little jumper wire now on the other lug.
Well, jump in. Work great.
Okay, and you're not pushing it down, obviously, right?
No.
It's taking it right out of your hand. Okay, so all that does is creates an electromagnetic field when I energize that coil, and it makes a, take your finger right away there now. It makes an electrical connection between those 2 posts, and when I let go of the power, it drops it back. Now I doubt it will pull it all the way down from up here.
Here's the balance.
This, yeah, there you go. Keep your finger right up high. Can you make it straight?
Well, good grief.
There you go. What'd you do, Don? You broke it.
I didn't break it.
Oh, you know what? It's not. Push it down just a little bit. Did it take it from you? Yeah, it's not strong enough to. There we go. So it won't pull it all the way. The magnetic field, it has to be down in close proximity before it'll turn it on. But anyway, you get the idea, right? Is that pretty clear?
Yep.
All right, so I wanted to just show you in this book. Let me see if I can find them quick. These do come in a bunch of different styles. Here we go. You can zoom in on this if you can. So these pictures show how every one of these are wired, and there are a number of different types that are wired in different ways, and they do different things. Okay? There's 24 volt, there's 12 volt, there's intermittent duty, there's continuous duty, there's all kinds of different ones. All of our spray trucks all use the exact same solenoid, so you're never gonna have to get worried about that. The primary purpose of this video is to teach you how to diagnose why you don't have power in the field, and it's important for you to know how these work in order to understand, what's not working. So let's come back up here. Now that you understand how a solenoid works, where'd my paper towels go? Throw me that rag. Right here. This will work. So on our vehicles, every one of them, we have a battery with a negative and a positive, okay? Usually behind the seat of the truck, we have a solenoid or 2 solenoids mounted to the wall, to the back of the cab, that have 3 studs on them, 2 big ones and a small one. Normally, there is a heavy wire, 10 gauge or large, or sometimes a battery cable, ran from the positive terminal of the battery under the hood of the truck to one side or the other of this solenoid. Doesn't make any difference which side it is. The other side of that solenoid runs to the spray console, and it goes to a number of different places. It goes to the hose reel, it goes to the electric starter of the pump if it has one, it goes to the two-way radio, it goes to the spray console in the cab, it goes to every place that requires power in the truck coming off from this solenoid, okay? So here we're gonna say, I'm just gonna call this load, okay? It goes out to the load. And then this third wire, this little wire, normally goes to the fuse panel of the truck, okay? And what we do is we find a fuse in the truck that turns on when you turn the key on to the vehicle. And if we take this wire and we hook it to that fuse, and we do that with a little jumper assembly that I'll show you when we go out there. If you hook that wire to the fuse, when you turn the ignition on to the vehicle, it will energize this coil, and this coil is a very low amperage draw, so you don't have to worry about it burning up the wire or burning up the fuse usually, because the draw on this is quite low. So by turning the ignition on to the vehicle, it trips this solenoid, which causes power to flow through it and to energize everything that's in our spray system. Okay? There's a couple other elements that are usually included in this. Usually right here we have some sort of a breaker. That's basically a fuse, a resettable fuse, so that if we draw too much power, if something gets shorted out, it'll trip the breaker. Okay? Sometimes, oftentimes, we'll have two solenoids behind the seat. The purpose of two solenoids is simply to split the load up so we don't put too much load through one of these. When we have two solenoids, what we do is we just jump power from here to here, and we jump power from here to here. And what happens is when you turn the key on, you've now tripped two solenoids, and you have two power outlets that you can send power out to the vehicle without having too many wires or too much load just on one. Does that make sense? Mm-hmm. This is real simple, right? Mm-hmm. So, at any particular time when the truck's shut off, I should be able to take a test light, just an ordinary test light, clip a test light to ground, which the mounting brackets for these solenoids are all grounded. So if I just clip to the bolt that holds this solenoid to the firewall, okay, I should be able to clip this to ground. I'm going to hold it right here so you can see that. And with the key in the off position, what should I have right here?
Power.
I should have power. My test light should light even with the key off, right?
Right.
With the key in the off position, what should I have here?
No power.
No power. With the key in the off position, what should I have here?
No power.
No power. Okay? If I turn the key on, should I have power here?
Key on, yes.
Key on, this should have power on it coming from my fuse panel, right?
Correct.
Key on,
Power.
should this have power?
Yes.
This should have power, and also I should have power out in my entire vehicle, right?
Correct.
So, if I turn the key on, and I have power here, but I don't have power here, what does that tell me?
Bad solenoid.
Bad solenoid or bad ground. If the solenoid's not grounded properly, the solenoid won't make its connection and it won't trip and send power through it, right? So what I could do in that case is I could just take a little jumper wire, touch the body of the solenoid, and touch ground. And with the key on, I should hear a click, and I should get a light right there, right?
Right, if the ground is bad.
If the ground is bad. If I do that and I still don't get anything, that's indicating that I have a bad solenoid, right? If I need to get back to work because Al's bitching, I can take this wire off right here and move it over here and put it on right there, and now I'm powering up my entire spray system continuously. The problem with that is, at the end of the day when I shut the vehicle off, all the spray stuff is not going to shut off. But that's a way to at least get back to work until you can get to a point that you can get a solenoid. Or there's another option, if you have two solenoids and you test power here with the key on and you don't have any power, but when you test it here you do have power,
Move everything over there.
Everything
you can
else.
take all the wires off from this and just move it over here and put them all on this. Now what we've effectively done is eliminated this from the system, and we're running our entire system off from this solenoid, right? Shouldn't be a problem as long as we don't run too many things at once. If we don't have the hose reel running at the same time we're trying to start the motor, at the same time the computer's on, at the same time we're talking on the two-way radio, and so on, you should be able to get by with that. At least get by until you can get parts to change it, okay? If I've got my ground hooked to ground and I check for power here and I don't have any power, what's that tell me?
Breaker.
Maybe the breaker, maybe a bad connection at the battery, maybe a bad battery, maybe a broken wire, right? One of those potentials. All right, so I need to look this way to find where the problem is. If I check for power here with the key on and I don't have any power, where's my problem likely?
Fuse.
Could be your fuse panel.
Probably in the fuse panel or this wire being broken. Easy way to test this. Take a little jumper wire. If you have the little ones like this that I bought at Harbor Freight for like $1.99, you could take this wire and you could touch it here and here. What would that do?
Powered up.
That would power up the solenoid. It would tell you whether the solenoid's bad or not, right? I mean, if there's no power here, it's probably not a bad solenoid. But just to double check it, you could touch here and here, turn the solenoid on, you'd hear it click, and probably your whole spray system would turn on. That would tell you that there is definitely a problem in this wire. Usually what the problem is there's a little fuse right here that blows, or this is usually located on the Ford trucks. It's located in the passenger side down by your feet. So a guy's down there kind of kicking around and he might dislodge this wire because it's just a spade connector that plugs into the fuse panel. So you can follow that wire back, find that wire where it's supplying power, and just do a couple of tests. We're going to go out to a truck here in a minute and do this. A couple of tests with a test light, you can tell what's going on and get it fixed. Okay? You could take a jumper wire like this, hook a jumper wire here to here, turn the solenoid on and go back to work until you got time to monkey with it further or whatever the case may be. Okay? This gets continuous power, so putting a jumper across these is not a bad thing. Problem is, at the end of the day, when you turn the key off, it's not going to shut the solenoid off. You're going to have to remove this wire in order to shut the power off to the solenoid. Okay? So, let's look at a couple of these other solenoids here now that we've learned what they do and so on. So what we got here, we've talked about that solenoid and that solenoid. These are just different shapes and sizes of the same thing. This has two small posts. When I put positive and ground, inside that solenoid is a little thing that's moving and it's connecting these two lugs when I do that, okay? That's how that one works. Here's another one, different shape. Same job, okay? It's just crossing those two, connecting them together. We already looked at that one. Here's another one. This one is got 3 studs. This one has to be grounded externally. Okay, making a connection between the two. All right, so here's what we commonly use as our breaker. So what we're going to do is build our system here quick. I've got my power. I'm going to use my, hopefully this works. I'm going to use my solenoid that we use in our trucks. Okay, that's going to come up and be powered there. I'm going to hook ground here to the frame. My load is going to be this test light, so I'm going to run my test light there. Don, you're going to hold the test light right here. Okay. From my fuse panel, I'm going to run to my ignition switch, we're going to call this. And then from my ignition switch, we're going to run to, oh, let's see. Oh, must be the switches on. Okay. Everybody understand that wiring?
Yep.
Okay. So when I turn the key on, the solenoid turns on. But the light didn't light. Why not? if I don't have power at my solenoid here, I should check and see if I have power over here. I have power here, right? Or we can check it. Let's see what we got. See if you got power here. Got power there. Okay. You should have power here too.
Breaker's tripped.
No power here. I'm not getting power into my solenoid. I can hear it clicking, but I don't have any power to this stud because that is powered separately. Remember from our drawing, this is powered separately from this. This is getting its power from the fuse panel, right? This is getting its power from the battery. So I need to follow my battery cable back. And what do I see right here? My power is tripped right here. So if I come back here to my breaker, which is usually under the hood, I test power on one side of the breaker, no power. I test power on the other side of the breaker, oh, I got power. I reset my breaker. Now I have power coming out of it. Now I have power going into my solenoid. Now hold that there. Okay. Now, doesn't help that we got a bit old rusty. Make sense? Okay, now, if I lose power from my fuse panel, solenoid doesn't work. How do I test it?
Jumper.
Well, I can check here. I'm not getting any power there when I turn the key on. I check here, I got power there, right? So this is telling me that there's a problem with the exciter wire coming from the fuse panel, right? So what I could do to test that is I could just say, okay, we're gonna take a little jumper and we're gonna jump across these. Put your test light back on here. Okay, see that? So I know my problem is in my wire coming back to my key switch, which is in my fuse panel. And in this case, obviously, I just unhooked it. Okay, that could be the cause. Now let's see what it looks like when we dump ground. If I don't have any ground, and how would we lose ground? If the bolts came loose or got corroded or something that hold the solenoid against the back of the cab, you would lose ground. So I'm sitting here now going, I get nothing here. Let's do our test. We got power coming in. We got power coming in. Do we have power from our key? We got power from our key. What's that telling us? It's telling us maybe a bad solenoid, right?
Yep.
So how can I check to see if it's a bad solenoid? I could jump. Keep your test light on there. I could test to see if it's a bad solenoid by jumping across these. Still nothing's happening, right? Geez, I thought my solenoid must be bad, right? Not necessarily. Now hook a ground to it and make sure it runs to ground, okay? And we work again. Is there any scenarios that I've missed? Okay, hopefully that makes sense, seeing it all right here. Let's walk out to the truck and we're gonna do a quick diagnosis of a problem that this truck has no power to the spray computer. I'm gonna bring a couple of jumper wires with me. All right, follow me out.